NHDC Limited, that is Narmada Hydro Development
This call
Corporation
is now
Limited,
being recorded.
which is a joint venture of Ministry of Hydropower, that is NHPC, the one PSU, and the Madhya Pradesh government. Faraz has been our very distinguished alumnus. He has been associated with Robo Club since its inception and has been writer of many research papers. He has been few granted patents also, and he has joined the this NHDC few years back. And because this is an industrial talk, we had a talk of Professor Tapan Saha in the afternoon. That was academic talk. He was a great man from IEEE. He was a fellow of IEEE. And I welcome you, Faraz. And we expect that this talk will be an interactive one. I also request the students to ask as many questions as possible with the Faraz. And Faraz has been the head of Robo Club also, and he has been actively associated with Robo Club also. All of you know it. I need not to mention it. And you can also take tips from Faraz that how you can run your branch more efficiently. And Faraz has been contributing to the Robo Club both academically as well as financially for many years. And he has been very active alumnus which of our college. So I welcome you, Faraz, again, and I hope this session will be an interactive one. And now over to you. Thank you.
Thank you, Zed. Uh, so, welcome everybody. My name is Faraz Ahmed. First of all, I have a small form that I would like to share. Hydropower stations, commercial design, and O&M aspects. So, as you all know, that energy is the need for the future, and the person who has power over energy and how to generate, so that is the powerful nation. And everybody is trying how to optimize the resources, because you cannot just have coal, burn it, and run a turbine and machines and develop 100% efficiency. You need to optimize it. Every drop of water counts. So today's lecture is based on that. Further, I have some. Yeah, coming to the presentation. I hope it's visible to all. Am I audible?
Yes, yes, you are audible as well as visible.
Yeah.
You can go ahead.
Okay, thank you. I'll be turning off my camera so that the presentation does not look off. So I did my BTech in 2013 in electrical. Then I was the research assistant in IIT Delhi for 1 year, where I worked on industrial robotics. And after that, I went to NIT Srinagar for MTech. But in the meanwhile, the job offer came, and it was I cannot say no to it. So I joined as as a trainee engineer in NHDC Limited. NHDC Limited is basically joint venture of NHPC Limited and Madhya Pradesh government. So the entire Narmada basin, the power that the water that goes through the entire Narmada basin, we regulate the power. In today's lecture, we will be talking about the commercial aspects. Basically, today's lecture is designed so that you have an insight on how the industry works. Electricity is not just this 4-year course that you are learning or the thing that lights up your house, but it is much more than that. So I will be covering these 4 aspects, and I'm sure that you all must be preparing in these 4 years about various components and basically the O&M thing. How are generators functioning, what are the troubleshootings you can do, what is the basis of electrical generation and development in all those areas. But the other 3 sectors you are not aware of. So today we'll be dealing with that. What I aim is that your current curriculum that you're studying in these 4 years, how is it applicable in the industry? I'll give you a brief about it as and when required. The insights into the industrial requirements. What happens that when you qualify for any examination, say GATE, and you land up in a PSU, then the first stage to get into a PSU is not just your grade score but also your interview. So After this, you will be having a fair idea of what the industry requires from a student to get to work for them, and then widening the horizon. See, like engineering is just a word. Electrical engineering is a part of engineering, but that doesn't restrict you to stick to electrical and learn nothing else. As one of our teachers of, I can say, very very senior faculty, a senior person, Dr. Akhtar Kalam in Australia, actually said a person who knows only electrical engineer is a horrible power engineer. So you need to learn many things apart from that. I think that will concur on that. So let's start with the first topic for today. That is the commercial aspect. So basically, what is electricity business? The finances and the costings involved. What are resettlements and rehabilitation? These are the things that will help you understand why there are so many andolans and so protests regarding setting up of power plants, be it in Kudankulam, a nuclear power plant, be it in Narmada Basin itself, or anywhere else in the Uttarakhand or Himachal Pradesh. So electricity, it's a business. It's like any other business. If you are say manufacturing textile, it is an industry. It is a business. If you are manufacturing a car, it is a business. If you are making soap, handmade soap, it is a business. And everything is a business there that feeds to the requirement of the consumer. So once it is a business, and there are several laws applied to it, because you cannot just do a monopolistic business in the market. You just cannot charge any value. You just cannot harass the customers. So you have to be covered under certain law. As per the constitution, if there is certain commodity, then it has to be available to everybody equally. So we had certain laws. I'm not going to go in deeply into these, but one thing I would like to tell, that these Electricity Regulatory Commission Act, Supply Act, Indian Electricity Act, Electricity Act 2003, what they all did was decentralize the business of electricity. Initially, the power generation was under the government hand, but later on, and eventually it tried to give the power to generate, to harvest the resources to other private players as well. It decentralized, say, and the UP Electricity Board. It was decentralized under 27 other electricity boards or corporations. So you have UPPCL, UPRUVNL. So all these limited corporations that were developed, including ours, NHPC Limited or NHPC Limited. So these were all set up just because they wanted to have a proper and a quite efficient administration into the electricity business. So as I earlier stated that electricity is just like another commodity. Say it is a soap, like a soap. So if there is a demand, then a company is producing it and selling it in the market. So here what we have the factory is basically the power plant. Let me Yeah. So the factory, it is basically the power plant. The product that we deliver is electricity. The cost, it is fixed by a power purchase agreement. It has no fluctuations like the other commodities in the market, like rice and wheat and onions. So that if demand rises, then cost of the product rises. So here we have a proper power purchase agreement with the government, where we decide at what rate the electricity should be sold. The consumers are industries, households, agriculture, etc. And the responsibility for this company, the power generation company, lies for power quality and grid stability. So this is a very big responsibility, because if any person comes and he starts selling electricity at a very low voltage or an abrupt frequency, no would be benefited by it. So just to keep a check on the quality of the business, we have this power quality and grid stability. So this commodity, other commodities, what you can do, you can just produce, stack it up, and forget. Whenever there is a demand coming, you can just pick something from the stockpile and sell it. But in electricity, electrical engineering, electricity is not such a commodity that can be stored in large amounts. Obviously, it can be stored in inertial wheels and big battery banks, but that is only for a transient stage, or say a very limited supply can be produced by it. And nowadays, many huge battery banks are being used, but they are being used with other power electronic devices so as to improve the quality of power. So let's compare how other businesses and electricity businesses are related. So on the left we have our electricity. I have shown it by a bulb, and say I have another person who is wanting to establish a taxi cab company. So I'll just portray the similarities between both of them. In electricity development, or sorry, electricity generation or powerhouses, the whole company is set up, and it requires its running costs and infrastructure development and some miscellaneous expenditures as well. So these three areas are basically the key areas where a person has to think and develop a business model that will benefit to the company, as in generate profits, provide employment. Along with that, it ensures the growth of the corporation, and the most important thing, it keeps itself upgrading so as to compete with other players. The same is with any other company. Say, in our case, uh, a cab owner, he has in his mind that he'll purchase say about 20 cars of certain brand, certain model, and to develop that infrastructure, he needs some money. And running cost, in his case, it's the diesel, it's the cost of the drivers, it's the toll cost, everything. So he has those things in mind when starting a business. And miscellaneous other expenses, say insurance is there, then upgradation is there. So these many things are required when you talk about a business. So for a usable life, if we say the factor cost of a power plant, so these are the costs that is mandatorily required apart from other miscellaneous requirements. So when we talked about the three structures of a business, well, the first was the infrastructure development. So you need for the infrastructure development, the first and the foremost thing is you need clearances. So the fees that you pay towards environmental clearances, forest clearances, and all sorts of clearances. So you have to pay certain fees. So that has to be covered. So why these are very small terms, very small amount. It won't even cost say 0.001% of the entire corporation corpus. But it is why I'm saying this, because you should keep this in mind that any factory or any establishment doesn't set up without these clearances. There are many clearances you have to invest. You have to keep in mind that you have to take the clearances. You have to pay for them. And payment is not the only thing. The mandate that is required in the complete process. You would be employing a particular person or a team of people or lawyers or experts who will get these clearances, and their salary, their travel allowances, their allowance, DNS allowances. So you have to pay all this. You have to keep those in mind. When you talk about a taxi service, then you have to purchase a car, you have to hire drivers, you have to advertise your agency, you have to create an application or basically some sort of a media that brings your consumers closer to you. Talking about a power plant, so you need to purchase equipment. In our case, we have to purchase generators, turbines, transformers, uh, other auxiliary equipments, governors. Then construction, it requires a huge investment in construction. Then manpower development, definitely you'll need to have a big team. When you have this generation, you're wanting a generation, say you plan for 25 years, 35 years, 45 years, or 50 years, then you need to plan accordingly how much manpower you require in the beginning, then during your operation and maintenance time, then during the operation time. A major cost that is required is in resettlement and rehabilitation. I'll talk about it in detail in coming slides. Now talking about the running costs, so for a taxi, we have fuel charges, then application app service charges, then driver's salary, the insurance premium you have to pay for all your assets, be it the car, be it the driver himself. So a driver is an asset to your company. So you'll have to pay for their insurances. Suppose there is a breakdown, then maintenance and breakdown that has to be covered. So those come under the running cost. Then upgradation, if there are new features available and which can improve the efficiency of your cab service, then definitely you'll go for that. While talking about the running expenses of power plant, so fuel charges, definitely there are some fuel charges. In the case of a hydropower plant, it's nil, nothing. We don't have to pay anything towards the fuel. However, we invest a lot of the cost just to store this fuel. So that is the reservoir that we have built. So basically, because of a dam we have constructed, and the cost of the dam, the cost of the civil structure, it is way too large. Then, the whole project can, as compared to the other components in the whole project. Then auxiliary consumptions for starting a generator, it's not like that. Just press a button and it gets started. Or even pressing a button, or even initiating any control command, you need electricity, you need power as auxiliary inputs. So all those auxiliary consumptions, be it even for controlling, that means your electrical part, or be it for lubrication, that's where your oil comes in, lubricants come in, or for cooling purpose, where your water comes in. So all these auxiliary consumptions are accounted for while thinking about a business of manufacturing electricity or generation electricity. Then salaries of the employees. So we have this corollary here. The driver's salary and the salaries of employee is one of the components. Then upgradation and retrofitting. You all know that while electricity generation industry, there are technological advancements every day, and the power electronic circuits are getting better and better. Their efficiency is improving, and so is the control system improving. So how best we can achieve these technological improvements? So we have to invest some cost to buy that technology to use it in then maintenance and breakdown I have already told about. So there is something called as preventive maintenance or corrective maintenance. You have to be prepared for all those things. And suppose if there is a breakdown, then how much cost will be incurred in fixing it. So you have to maintain certain mandatory spares for each turbine generators or other auxiliary systems, so that in case the machine runs or goes out of service or breaks down, then you can fix that. So all these costs are including in the running cost. And then a major portion again is insurance. So while talking about insurance, I must tell that yeah, the civil structures, suppose the dams, the intakes, the HRC, the TRC, all these things are insured, because we know that the forces of nature are too big to handle. And however the strong structures we build, definitely we might face some problems. So we ensure those things so that our business does not fail. See, we have shifted from socialistic point of view to a bit of capitalism, or basically, how should I put this? In socialist forms, the government takes all the responsibilities, providing subsidies or and taking up all the losses, absorbing all the losses. So that is not good for the government. So what it did, it decentralized and asked every agency to generate its own profits and to work within those limits. So the higher the profit, the better is the employees' working conditions, the salaries, allowances, everything. And if a company is making a loss, then that transfers onto the employees itself. So all these things, they are covered in the costing and the finances of power plants. Now, this thing I would like to talk about. What is the time? I guess 18 minutes have passed. I should hurry. So this interest on loans. So while setting up either your taxi services or a power plant, you need to take some loan. You have to account for the interest that you will be paying in the long run. Say for a taxi service, if you're taking a personal loan or a corporate loan of 7 years and with say approximately 10% per annum. So that 10% per annum, that will be reflected in the total cost of your company, and that will be reflected in the amount you will be setting up for the sale of your services or the product. Then profit margin, obviously you need to grow, so you will be envisaging some profits. Then contingency, that is a very important thing. However, we take insurances, but still there happens some time that insurance money doesn't come on time. So we have some contingency fund from where we can spend at the time of emergency. And depreciation in your engineering economics, there are each and everything that I'm talking about, especially this depreciation part. Any asset that you have bought, machinery you have bought. So that has a useful life, and throughout its useful life, its value degrades over time. So that is depreciation. So you have to keep in mind everything. This is a negative concept. So basically, you have thought you bought a car, say for a taxi service company. You purchased a Maruti Swift Desire, and it costs 7 lakh rupees today. But the cost depreciates so fast that if you're going to sell it in a month or two, it will cost 1 lakh rupees. So this difference, that should be reflected in your business model. That should be reflected in your costing. That should be reflected while preparing the financial statements. Otherwise, you have envisaged losses, where you have envisaged your profits, where you have envisaged your growth. Club it together and divide it by the amount you're going to produce. So that will be the cost of your individual item. I hope I'm clear. Clear. If there are any questions, you can kindly put it in chat. Is oh fine. So next thing I wanted to talk about was resettlement. See, this is a very long presentation, and I don't think it will be covered in a single session. I may be taking one session someday else, but that will not appear in any of the textbooks. I'll be telling you over here. So what about resettlements and rehabilitation? You move you move men, you move means of livelihood, you move culture, you move traditions out of a place just to create a factory or a power plant. So that has many financial, so that can be taken care of, and emotional values as well. So where you are living, if somebody says today that this whole area of say 10 square kilometers is going to be submerged in 1 year, and anything that you have here will amount to zero. So that will enrage you. That will instill a feeling that things are not going straight. Things are against us. However, the Constitution provides that if anything government wants, they can do it, but they should be providing suitable compensation. Of the order that these movements, emotional, we cannot assess them, but these movements of men and means of livelihood, if they are carried out, then there are no drastic consequences on the people. However, there always are. So sorry for the interruption. So, okay, fine. Continuing again. Acquiring new land and suitable clearances is one thing. So you invest a lot in acquiring a land. Now that land can be a forest land, can be an urban land, can be a rural land, can be a place inhabited by people or animals, can be a place not inhabited like a plain desert. But even for deserts, there are creatures who are living. So you have to rehabilitate, you have to resettle all of those single creature out of that place where you're building your empire, your factory. So construction, since you're moving, so you'll be providing them new settlements, so roads, railway lines, hospitals, school, markets, residences, community centers, places of worship, and many other things, like crematorium. You have to provide in order to resettle those places. I think you know this person. Can I know if you know this person? Do you know who is she? I'm getting no responses. Please, people, don't speak. Okay, Munif Khan, you don't know. Fine. Prajwal, Shahrukh, Abbas, anybody? Zeb? Okay, fine. She is Medha Patkar, and this is the Narmada Bachao Andolan, and it took place on the basin where we are currently working. So not exactly on our location, but downstream towards Sardar Sarovar and in Gujarat areas. Then cost is involved in transporting men and material, provision of suitable, sustainable and suitable livelihood. A farmer who has been displaced, he has to be provided with the land, and such a land that is agriculturally viable. You cannot shift him from a fertile land to a barren land. So all these issues, yeah, you must be remembering that by many highway projects are there when JP built expressways from Noida to Agra. So there were many farmers protesting. That was because they had the fertile land and wanted a suitable compensation. So the government enacted a land acquisition and rehabilitation and resettlement act that helps those people to provide proper livelihood, and in our cases compensation in form of monetary means were given, and apart from that jobs were offered to the eligible people in the areas. So there is a kind of a reservation for the people who are working in the corporation, for all those people who have been affected by the submergence of their places. And this arbitration, it takes a lot of time. It takes so many days. कहते हैं ना वो तारीख पे तारीख तारीख पे तारीख, तो वो हर तारीख में एक एडवोकेट हमारे साइड से एक एडवोकेट उन लोगों को जो रिप्रेजेंट कर रहा है वो जाता है, वो फ्री में नहीं जाता है, वो उनसे पैसा लेता है, उसका पैसा। वो लोग तो कंट्रीब्यूट करके अपना चला लेंगे काम, लेकिन हम एज अ कॉर्पोरेशन, एज अ बिजनेस, एज एन इंडस्ट्री, वी हैव टू कीप इन माइंड कि आर्बिट्रेशन का भी पैसा हमें ऐड करना है। तो वंस ऑल दीज फाइनेंसेस आर टेकन केयर ऑफ, हम लोग ये डिसाइड करते हैं, बट एक्चुअली ये पहले डिसाइड हो जाता है कि हमें किसे पावर सेल करनी है। तो वंस वी डिसाइड कि हमें किसे पावर सेल करनी है, वी ड्राफ्ट, वी मेक अ डीपीआर, डिटेल्ड प्रोजेक्ट रिपोर्ट, एंड वी डू ऑल द काउंटिंग कि कितना पैसा हमें लगाना है, कितना पैसा हमें कहीं और से मिल सकता है। तो आफ्टर वर्किंग our electricity to a particular person or an entity or a state or to the government of India at such and such cost. Now, when I talk about this, so just for a fact, it's nearly 1 rupee 67 paisa per unit of electricity, per kilowatt hour of electricity that we are selling. And when it is raining, when it is flooding, and when surplus, we have surplus amount of water, then at those times it goes as low as 0.94 rupees per unit. Fine. So let's talk about the design. Any questions so far? I'll be pausing for 1 minute. So any questions so far? I thought this would be interactive, but I see nobody is quite. Okay, fine. Since there is time constraint, I won't be waiting for everybody. Let's move on. The designing of a hydropower plant. So, what are the basic requirements that you have to keep in mind while designing a power plant? The geographical factors and R&R we have already talked about. Then the civil design, electromechanical design, and cost optimization. Sorry. So the general requirement is how much electricity is required. As a producer, you need to know what is where what the thing should be, how much is required to be generated, because we cannot export electricity like other commodities. So you need to know how much electricity is basically required. So who gives that data? The POSOCO and the power grid and the load dispatch centers. They give the data that we require so much electricity in the coming days. How they do it? They do it by forecasting. There is load forecast going on. So based on the past users, the consumers' requirements, they prepare and they extrapolate, and along with other several factors, the political factors like there's going to be election, and sociological factors like some religious festival is there, like Diwali is coming. So you need to envisage you beforehand. You need to forecast how much electricity is going to be required. So that is done on a basis of every 15 minutes. That is there is a block of 15 minutes, a standard block that is followed in every power plant. So you have to know the requirement of electricity for each block. Then 15 minutes a day, 10 days, 100 days, 365 days, and going on to several years, say 20 years, how much electricity would be required after 20 years. Because if there is a demand rising, then you cannot just start and finish up in a month and start generating. It takes, every power plant takes some years, 4 years, 5 years to build. So you need to envisage beforehand how much electricity is really required. Once that is done, you plan accordingly. So all these data, they play a crucial role. We as electrical engineer, any corporation, we may think that we have a very small role in doing monotonous operations, operating a turbine generating unit. But all these small units, they come together to give a bigger picture of the power industry. So if you have time someday, you can go onto the power ministry site and see there are various reports and how they manage and control. Regarding control, I would come to that. Okay, geographical factors, basically, while talking specifically of a hydropower plant, so you need to choose your areas very intelligently, because for hydro, the main thing is water. Apart from the Himalayan rivers, all the other rivers are fed by rainwater. So once there is rain, there is water, you can generate. But if there is no rain, then you have to have suitable arrangement to store the water, and that's what is called a dam. As a matter of fact, the Indrasagar Dam, the reservoir it creates, is the largest reservoir in India. So it is like a small sea in the middle of our nation. So for that, where the water will come from, how much water will come, you have 10 years data, last 100 years data, annual data, 10-day data to tell you how much rainfall is there and how much are the flood discharge in that particular time. So the flood discharge for the last 100 years, maximum flood discharge is taken as the maximum capacity of that catchment area where you're going to build it. Then water utilization by human beings, by flora and fauna, you cannot just put logs and build a dam and disrupting everybody's power supply. You may know that there are a lot of trouble going with India Pak Indus water treaty. So that is all about this utilization of water. Pakistan says we need certain amount of water. India says these rivers are the sources of these rivers are within our boundaries, and we also need water for our electrical generation for drinking purposes. We just cannot hand everything over to you. So there's a tribunal, a committee was set up, the Indus Water Treaty was made, where effective utilization of water for every season, for every day, for a particular month, has been decided that this much water has to be given downstream to the other nation, and this much has to be utilized by our own nation. Then flora and fauna, it depends on water. You cannot just cut off the water entirely just to save the water and let them exist. There are beings on the planet Earth, but there are flora and fauna that helps us to stabilize and create a balance between a different livelihoods. Then geological stability, it is very important, because when you are going to store a huge amount of water, a huge amount. I'm talking about billions and billions of cubic meter of water. So if you're talking about that, then the weight of that water, it has to hold onto the crust of the earth. So you cannot build on a very weak substrata. So once you start building, you start raising the level of water. At a certain time, there would be fractures in the crust, and all the water will seep down to the lower crust. And then the dam, it's a heavy structure, so you need to know how well it will be stabilized on a particular rock. So here the civil engineers and geologists come. They design an optimized structure for every place. In case of Indra Sagar Dam, where I'm currently working, there happened to be a bottleneck in the whole submergence area, and we built a dam there. So it was cost effective. It is built up over fault zone, shear zone. So that is a very dangerous if anybody from civil has joined. So it is a very unstable zone, but suitable methods have been taken to stabilize it. So you need to see, you need to get the feel that it's not only electrical engineering that is working behind power plants. It's the civil engineers, chemical engineers, geologists, mechanical engineers. Everybody comes together, forms a team, and then implements it. Then social environmental aspects you have to see. Ecological balance, as I told earlier, natural resources, timbers, herb, forests. You cannot just submerge any area into a reservoir that has a very valuable medicinal herb, because this is the resource. You have to have a trade-off between what to do and what not to do. This is the resource that our nation has. We cannot just submerge everything. Then accessibility for transportation of men, material, and produce electricity. NHPC has a lot many sites. National Hydropower Corporation has lot many sites. Where reaching there is a big trouble. Some places require transportation of and or all four of them. So even a 30-kilometer ride in any of the power plants can consume easily 4 hours to 5 hours of your journey. So then, in terms of electricity, there should be low transmission losses. So if you're selling to a particular state, say Rajasthan, and you think that I'm getting a very low-cost land in Tamil Nadu and I can build there, so that is a fool's idea. So you have to create a trade-off where to set up the plant so that there are lower transmission losses. Then closeness to the load, as I told, and habitability. You cannot just go and build the geothermal electricity is very good, but you cannot go into a volcano crater and establish your geothermal plant. So that has to be safe for the workers, for the employees, and for the people who are coming in visiting there. Then the civil design is there. So basically, a lot things are there. I will try to complete it in other lectures. But the basic structure of a dam, its capacity, the structure of a dam, it is designed so as to hold the capacity of the water behind it. The height is adjusted so as to give you the optimum head that is required to run a turbine. Then seismic stability, wind stability, all these things are there. Type of energy dissipation arrangement that I will cover in someday, some other day. Then the choice of dam, rock filled, earthen dam or concrete dam. So here cost is involved, stability is involved. So you choose a dam accordingly. Then water storage. Do you have to install on a river runoff like in Himalayan river? A lot many plants are run off the river. So there you don't hold the water. You let it flow, and parallelly you set up your power plant and divert some amount of water through your power plant so that the power is also generated and the net requirement of water is also not affected. Pondage that we have, you build a storage, you pump in all the water or from the rain and you utilize it. And the pump storage. Pump storage are very important and very necessary. There is a pond basically, and you discharge the water into a river at the time it is needed. What happens when there is a sufficient amount of electricity present in the grid, surplus amount? You suck in all the water and pump it back into that foundation. So whenever you need it in emergency, you can just plug it on and it will start working. Fine. Any questions so far?
Uh, I can accept all the points. However, can you please explain this temperature and temperature variations?
Just to say, right. Okay, fine. That is a very good question. Actually, what's your name, Prajwal? So what happens that the structure, it's the material you have put into a structure. So they have various properties, mechanical properties that may change their dimensions, subjected to variations in temperature. There is a power plant in Ladakh and there is a power plant in Kargil, Nimmobasko in Ladakh and Chutak power plant in Kargil. So all these power plants are located at a very high altitude. What happens there that water is freezing, the whole river is frozen on from the top, and the water that is required for generation has been taken from below it. So there is a temperature difference if you see vertically. So there is a temperature difference from top to the bottom. All those areas of the dam where this water is in contact with, so it will affect the dimensions of the steel bars inside the dam. It will change the properties of the cement holding it. So you have to design a dam so that all those effects by temperature variations are negligible. and in many places like in very hot climates. However, there are very few rivers in the tropical zone. But in very hot climate, what happens is, say, suppose in our power plant, the temperature rises to around 50 degrees centigrade, and big reservoir behind the dam, it plays a very different role in maintaining the balance. So what happens at one side of a dam, the concrete structure, it is 50 degrees centigrade, and the other side is 30 degrees centigrade because of so large amount of water. So water has a cooling properties. By convection, it cools itself. It is at 30 degrees centigrade only. But on the other side of a dam, say just 6 meter or 7 meter thick wall, many mechanical stresses that develop due to temperature. So I think you got that point.
Yes, exactly. So it must be quite difficult for this northern plains to difficult to construct a dam, as there is a very highly variable temperature difference in these areas.
Not it is difficult. The choice of material that is different for northern parts and for southern parts. This has already
Okay.
been worked out. It is not something on the go that you go and do. Fine. So if you have any further questions regarding this specific thing, we can cover it some other time. We have already consumed 40 minutes and a lot to go. We are just reached halfway. Now, talking about the mechanical design, so I will provide you with the. Okay, fine. Let me see. So the this mechanical design is basically I'm sharing the screen. Did you all get it? So you can save this video. It is after a long searching that I have come across this. So it is a structure of the complete hydro power plant. So all those who have started, if you get on to 18 seconds, you will see that there is a penstock that is bringing in the water to the turbine, which is situated at a lower level. The water then falls through, if you click on there, the water then flows through the turbine. There is the spiral casing which equalizes the force of the water passing through the turbine blades. The water then goes down through the draft tube. The turbine is connected to the generator through generating shafts. There are several brackets to hold it in place because it's a very huge structure and a very bulky one. So you need many mechanical supports to keep that in place and to avoid deviation. And that is coupled to a generator. So this is a complete video you can just see on your own time. And I will be moving ahead now. You have that empirical formula. Is that formula where the amount of energy generated is proportional to the head of the water column, the discharge through the turbine. So when you design for a power plant, you get to know the discharge from your 10 years or 100 years data, that how much water is coming from the upstream. In case of a storage power plant, you don't need to worry because you know that for a specific height and for a specific size of a penstock, there has to be certain dispatch based on the discharge and the height. You and the head, sorry, you get to know how much electricity is being generated. So firstly, what happens? You have an amount of electricity that is required coming from the first few slides. So why you have to produce those many electrical units? You have those power that you have got basically the required electricity. So doing the reverse engineering, what you get to know is how much should be the head is fixed because of the geological constraints. The head is fixed. You cannot have a 60-meter dam go up to 100 meters, and resettlement R&R issues are there. So you can submerge the whole of the continent just for raising the head to say 1,000 meters or 700 meters or something like that. So the head of a power plant is fixed, and the amount of electricity that you require is fixed. The only thing that is variable here is a discharge. So when once you get the amount of discharge that is required, you design the penstock, the spiral casing, and the duct tube accordingly. And the material and the strength of the mechanical structure that depends on normal conditions as well as the surge or transient conditions. So there are places where the penstock is several kilometers long. So there is water hammering. There is some particular effect water hammering that whenever water stops or whenever water flows in a long channel, then it creates forces, transient forces throughout its flow. So there are such tanks provided to deal with them. But in our power plant, nothing is there because we have a, only 150-meter penstock length. So during normal conditions or during the surges, you need to envisage how much would be the mechanical stresses. So the choice of the material, the design of the material. So it all depends on that. Coming on to the design of turbine, definitely reaction or impulse. Impulse turbines are used for high head power plants where the head is so large that the force of the pressure exerted by the water, it hits a particular wheel, say a Pelton wheel or a turbo wheel, and because of this impulse, it rotates the turbines and the generators. But if to the turbine, then what we use a propeller type or a Kaplan type or a Francis type. In the presentation itself, I have given you the link, so you can just go through them. The spiral casing, as I told you, it's for force equalization because when the amount of water it gets distributed inside of a circular penstock inside the turbine, then the pressure decreases over the period. So in order to equalize the force that is being exerted on the each of the turbine blade, we design a spiral casing. Then there are wicket gates. Wicket gates are basically are nothing else but they are just to guide all the water in the spiral casing into the turbine. Then there are guide vanes. So basically, these are the guide vanes are the only things that help control the. Stop if you control basically the flow of water into the turbine, then you are controlling the power generated from the whole turbine generator system. So if you have to stop, you just close it dead. If you have to run it on a full efficiency or say on a full speed, then you open it to the maximum. Then there is a design of the governing system. So it's all about control systems and hydraulic. See, you all are mostly electrical engineers, I suppose, and you'll be studying about control in a very beautiful form. You can see it over here. So this governing system, what it does, it keeps a check on these guide vanes, how much to open, when to open, for how long should they be open. In case of an emergency, just force to open or close the gate. Since we're talking about the control systems and hydraulics, so there it has associated itself with a certain response time. So while designing a governing system, you need to have this in mind as well. So you cannot just have an emergency shutdown of 20 seconds. You have to get it done in within few 3 or 5 or 6 seconds. More than that, it will create a habit. There have been power plants where proper shutdown or a timely response of the system was not there, and the whole powerhouse was flooded. The machines were, in some cases, uprooted from its bases and thrown up in the air. So that's the amount of energy water has. I will show a video in the lab. If there is any active member, can you just remind me 7:55 so that I can start up the other section? Then after the design of governor, you have a generator. So generator, you have got the discharge. Now with the discharge, you are able to achieve certain RPM because of the design of the turbine. Now with that RPM, you need to achieve required frequency, that is 50. Since it is a synchronous generator, so all the RPM that is required to that will be the frequency of the frequency which will be generated. Since it is going to be connected to a grid, it has to be perfectly synchronous to the grid frequency, that is 50 Hz ideally. So while designing a generator, you have a constraint on its RPM in case of a power plant, because you have a constraint on the head of the plant, and then you have to design the penstocks and the discharge. So head and discharge, they are fixed. When discharge is fixed, the design of a turbine is fixed. When the design of a turbine is fixed, the rated RPM, the total output of the turbine, that is fixed for a given amount of force that is being converted from mechanical to electrical energy through generators. So you cannot have much variations in the dimension of a machine basically. So the machine that we have installed, generator, it has a diameter of nearly uh, 10 meters. So just imagine a 30-foot long, 30-foot wide rotor just to house for one 25 megawatt machine. Then when you have a rotor of that much width, you have to decide how many number of poles should be there, what should be the winding criteria, everything. Fine. Then cooling, natural air or water cooled, it is up to you. Structural strength, how you cannot just make a 500 watt megawatt machine for a design that is bearable for 100 megawatt. Talking about the electrical design, so there is a total power generation. So I have talked about this, that that how much is the discharge, how much is the effective head, what is the efficiency of the electrical efficiency of the generator, what is the mechanical efficiency of the turbine, because throughout this whole process there are a lot of frictions, and friction and mechanical forces acting opposite to what we require. So there are certain losses in that. Then number of poles So all this comes under the electrical design. The output voltage of the generator, that is very, very important, because that will tell you the amount of insulation that is required to be put on, because all the conductor that is on the rotor or on the stator, they are insulated from one another. If you go for a higher generating voltage, you will need to have more insulation over, or costlier insulation over the same conductors, and that will require more space. Voltage level of your generator, increase the number of at a very high voltage to generate at a low voltage and high current. Then coming turbine, the governing electrical design, if I'm talking about, is there is a governing system. So how much the gates should be open for a required RPM of the machine, because the grid is the grid operation in there, the frequency varies very instantaneously. Within few milliseconds, you can see the variations from 50.00 hertz to 50.01 or 02 hertz. Now, in order to match this, the generators, since they have a very large inertia, the whole system has a very large inertia. So what happens that in order to get a particular response out of the machine, you need to design it accordingly. So that once the response frequency rises, then accordingly the frequency of our machine should also rise. There are some restrictions free governor mode operations. Hopefully, sometimes else we can discuss this. And then the turbine instrumentation, so the RPM, your speed meters you have. Then there is cooling, the water jacketing. There are seals that restrict the water from the penstock or the turbine to come and flood the cases. So you have the instrumentation everywhere. How much flow is there? How much of the water is there? Other instruments, supporting instruments are there, auxiliary instruments are there, flow meters are there. So you just keep an eye on all these things. Then there is a generating transformer. So as I told you, that lower voltage generation is done in order to save for the insulation and the dimension of the machine. So what you do, you generate at low voltages and at a high current. And in all that, there is you need to design the generating voltages and transmission voltages also. So the transformer, what it does is sets up the voltage, and you have certain restrictions on that by the Indian Standard Code. So you go accordingly. Then there is the ability to change tap offline or online. So these are the features provided in the transformer. Then is it a natural cooled, forced cooled, air core, or oil cooled? So type of cooling based on the amount of heat energy that is dissipated through the process of magnetic coupling. So this happens. Then auxiliary units are there. See, as I told that you just don't press a button and a machine starts. What happens? Even you for even pressing the button and the command to go through, you need to have some control signal that are generated, that are powered by unit auxiliary system, which is powered by the transformer. So you have to design accordingly. Then there is excitation transformer. You have rotor, the field windings on the rotor. So what you need to regulate it so as to meet the meet all the reactive power demand of the grid. So you change it accordingly. That is what excitation transformer design comes in. Then there are auxiliary systems like pumps are there. So you have to design a variable frequency drives for that, and how you can perform their operations effectively and efficiently. Then lighting and power backups, communication. After that, there is you have to design a switchyard. So all these generating units, they transfer their power through a generating transformer into a switchyard. So switchyard is nothing else but a switch with several protections. Since there is a lot of voltage that we're talking about 400 kilovolt of potential. So for that high voltage level, you cannot have a miniature circuit breaker to function for that. You need to have very long, say 50 or 60 meters wide by few hundred meters long switchyard or transfer base, just in order to keep the voltage level harmless, and so that they don't interact with each other as well. You cannot have two conductors running very close to each other. There will be discharge through the air gap that is not desired. Then you have protection and metering. You have to design that. You have communication. That PLCC system is there. Power line carrier communication. Nowadays, what is being done? There are OFC cables that are embedded into the ground wire. So ground wire optical fiber communication system is happening in India. So all this ground wire that runs atop the transmission lines. So they basically have OFC cables in them. So that is used for communication. Coming on to the next section, parts of a hydropower station. So I talked about water storage, the water conductor system, then the turbine I talked about, switchyard and dam I told. So let's brief up. The pondage is there or a river is there as a water source. Then there is a headrest channel. As I told that you cannot just disrupt the natural flow of water. So what you do if you're creating a barrage or a dam across it, then to also you need to take some the water from a different channel into the power house. The main reason being desilting and regular supply of water. You cannot have any unreliable sources. So what happens? You create a channel parallel to the river course and bring all that water through penstocks into the turbine. Then there is a silt basin in northern Himalaya, in Himalayan region. The river water brings a lot of silt with it. So there are silt basins in order to desilt them, desilt the water before going into the turbine. Because see, once the water with silt goes inside a turbine, it erodes the bottom of the turbine. Solid stainless steel of very high endurance, but yet the water, the force of the water, the erosional properties of the silt, it degrades it. Then there is a penstock that brings in water. Then the draft tube that discharges the water. There's this what it does. It basically after the energy has been transferred from the water into through the turbine, the leftover water is discharged. So all the water basically is discharged towards draft tube. So there, what happens? The force is minimized, and keep looking at the dynamics of the water in the whole process. People realize that the structure of the draft tube has to be such that it overcomes the dynamic forces of the water or the turbulent force of the water down in the draft tube. So it is designed accordingly. Then there is the dam. Dam, what it does is basically flood water spillways are there and irrigation channels are there to facilitate. So this is these are the parts of a hydropower station. Do I have the attention of everybody now? Fine. So this is Lake Aldwell from American place. Here, what I see, I cannot put up the plan of my power plant due to safety and security reasons. So this is Lake Adwell. They have controlled it, the water. They have stored the water by constructing this concrete system. You have this powerhouse over here, somewhere over here. This is the whole dam. Then these are for irrigation. These channels are for irrigation purposes. So you discharge some water for irrigation and for power generation over here. And these are some spill gates. These are spill gates. So then when and then it becomes uncontrollable basically. So all the water that is coming in will flow out. And in that course of action, it will destroy the structure of the dam, the superficial structure of the dam. So in order to avoid that, what is done is basically you create spillway channels and allow the water or basically regulate the water so that you have a constant supply of the water and maintain a constant balance of the water level. You must have heard recently in the news that Madhya Pradesh experienced many floods. So throughout these floods, the main function of the Indrasagar Dam was to control the amount of water being discharged into the downstream. The potential of the water is so much that it can uproot entire villages. You have seen in the Kedarnath tragedy back a few years back. So what happened that there was so much water, the cloudburst was there, and the whole village swept away. So since that should not happen, we control the flow of water going through the dam. This is the elevation. So all these places, these are for agricultural purposes. Then this thing, I think 14th number is overhead frame for manual wrench. Okay, and this is basically how a dam looks from the front. So you may not have this thing, you may not have this thing, you may even not have this thing. You can have only this thing. That's 1, 2, 10, and 11. So there is a powerhouse, there are discharge gate spillways, then there is a dam. Sorry, then there is a powerhouse complex. There is the water comes in, and you get the electricity out of it. Then there may be irrigation channels. So this is the cross section basically. So you have the lake or the water source. Now these 15, 16, 17, they are some kinds of some different kinds of rocks that have been shown. But over the period, what happens that this layer gets built up because of silt as well. So whatever the water comes in through rain or whatever media, it deposits the silt, and this has to be desilted every now and then. So there are activities of flushing. Then this is the dam. Regarding dam, I should say that the design of a dam, it is very important, and the choice of material that you use for constructing a dam has its dependence on the amount you are going to put in. The best is a concrete dam, but it is so costly that you cannot just put every corpus into constructing a dam out of concrete, which you can build out of mud or stone. Fine. This is Indrasagar Hydropower plant. So on my right here, it is the dam. So it has 20 spill gates for the same reason that it has to discharge a large amount of flood. And this is the HRC, this back water that you're seeing. So this is the natural river course that is going. We have diverted it using a headless channel. This is the powerhouse. It's situated inside this whole block. This mountain basically divides the HRC and the TRC. The machines are located over here. So this is the office for the operation people in the first floor of this complex. So this is how setup looks. So you generate all the electricity here. These wires the switch yard which is located over here. Fine. These are two kinds of spillways. It's the main spillway, and this is the auxiliary spillway. Suppose the flood amounts to such a larger inflows that this can not work. So we open these gates as well. So in addition to the discharge to these gates, you have discharge to auxiliary gates as well. Just for as a matter of fact, I should tell that a 200 square yard house of 17 floors, it gets flooded in 1 second. The amount of water that is being discharged during the flood season. Any questions so far?
I guess it was a bit clear.
But I should be moving. Fine. So this is the operation and
Yes,
maintenance.
yes, sir.
The operation and maintenance. I'll be sharing a link with you, so you can just post all your queries over there, or you can mail me. Regarding the O&M of hydropower plant, so what is basically once you are going to pass gate and you are thinking of a very high paid salaries in the PSU, so you should know what you are going to do over there. So as people say, many seniors even told us also that when we go into PSU and jobs, nothing that we learn in the 4 year matters. What matters is PowerPoint, Excel sheet, and MS Word, and they are completely wrong because they have not been into those fields where the requirement of core electrical is required. So say suppose one is a civil engineer and if he says कि हमारा वहाँ क्या काम है ये डैम तो बन चुका अब क्या करें. So this is the part, flood regulation. You have to figure out how much water is coming in and going out. Then the dam, it is a body that holds enormous amount of water behind it. So the strength, the you have to constantly keep checking how well the structure is performing. So many things are there. You have to get involved to do this. So there are preventive and corrective maintenance that I was talking about, retrofittings and upgradations. This shall be kept in for some other time, and expansion yes, this also for some other time. So what are the kinds of operation that happens in a hydropower plant? When you have built a dam, the first thing that comes into mind is इतना सारा पानी है, इसको सिंचाई के लिए इस्तेमाल करते हैं. We use it through irrigation channels for irrigation purposes. For drinking, obviously इतना सारा पानी आ गया इकट्ठा है एक जगह, प्यास लगनी है लोगों को, पानी हम यहीं से लेंगे because it has all its sediments settled into the place. The cost of filtering a plant, filtering water from the upstream is quite less as compared to the downstream. मैं यहाँ पर अगर प्लांट लगाता हूँ एक वाटर के लिए पानी पीने के लिए और उसमें मेरे को जितना खर्चा आएगा वो बहुत कम होगा अगर मैं वही प्लांट यहाँ डाउनस्ट्रीम में लगाता. तो आपका रिजर्वायर बनने से काफी अच्छा क्वालिटी का पानी आपको अवेलेबल होगा. देन फिशिंग, ऑब्वियसली इतना बड़ा पॉन्ड है तो मैंने इसमें मछलियां छोड़ दी एंड इट इज अ वेरी बिग इंडस्ट्री. So you get a tons of fish after breeding in such and is the most important is biodiversity. So when you have so much water, you have so much flora and fauna going because of it. You have so much uh, microorganisms growing, and apart from that, in such a large body, what it does, it transforms the weather of that particular place. So as I'm told that before the dam Indira Sagar Power Station was here, there were no vegetation in this whole area. It was like the Great Thar Desert, except that it was not a desert; it was just barren. But after the dam has been built, there is a big reservoir, and the climate automatically has evolved, has changed, and it's all lush green. If you search for Indra Power Station and the related areas like Hanumantiya and Omkareshwar, so you get to see the pictures. They're so beautiful just because of us storing so much amount of water behind a concrete structure. What functions or operations does a dam do? Dam is and it can discharge water. So when there are floods, you discharge it accordingly so that the downstream areas don't get flooded or submerged. So this is one of the functions that we are doing over here. Out of the three parts, that is one is the powerhouse over here, one is the flood regulation over here, and the other is a reservoir. So from all these things, we are doing only two works. We are not looking after the irrigation of fisheries, and this is the power generation. So all these two things we do. So as a power engineer in a hydropower plant, you would be deputed in anywhere of these places. So you'll be looking after the operation and the maintenance of a power plant. Why is maintenance required? Now, that is a very big question. When you talk about electrical and mechanical maintenance work, so these all are correlated. And I must remind you and warn you that being an electrical engineer does not mean you have to study only electrical engineering. You have to study mechanical, you have to study civil, even you have to study uh, chemical and other branches. Because all these things come into picture not in a natural course, but when there are breakdowns or when you're doing maintenance. So if you know how rusting can be prevented just by a simple knowledge of chemical engineering, or you can know how chemical erosions can be avoided, then definitely you can save life of the machine and the industry on a whole. So there are basically maintenance is required for two purposes to basically check on internal and external forces. So there are many internal forces that develop, and if when you not when you'll be not checking them, so they'll go out of hands and it will destroy the machine. There are many external forces. Even the pressure of the water is so high through very small orifices that it can help it can help erode the surface of well plastered surface of the body of the power plant. So if there is a small orifice, a small puncture in the pipeline that we're using for cooling, and the water comes out through that, so it is a very big thing. So in order to keep that check, you need to do what? First is the preventive maintenance. Daily कुछ ना कुछ चेक करते रहना है. एक हाउस होल्ड एग्जाम्पल मैं आपको बताता हूँ. घर के अंदर आपका बहुत सारे इंस्ट्रूमेंट्स रखे हैं. अगर आप उन्हें रेगुलरली नहीं देखें तो अल्टीमेटली व्हाट दे डू, दे डेवलप ट्रबल. एक माइक्रोवेव है, इफ यू डोंट रेगुलरली क्लीन इट, then all those oil sludge, it will deposit on the grill and may even catch fire upon heating at some point. Or say a very simple thing, if I should include, are the fans or the coolers or the air conditioners. You cannot keep them running throughout. You have to do their regular maintenance. You have to clean their inlets, their vents. You have to just invest some amount of time and money in order to check all the system whether they are running safe and sound. So that is called preventive maintenance. In our case, we have the turbine and generating system and numerous systems under that we have to regularly check on a daily basis, on 8 hourly basis, on weekly basis, monthly basis, quarterly basis, yearly basis, and some in 2 year basis. Apart from that, there is corrective maintenance. So what happens if a machine breaks down? The maintenance you're doing there is corrective maintenance because something needs to be corrected in order to get it working. So why do we need preventive maintenance? The only reason is because of the large inertia of the turbine generator system. It is a huge machine, and it is very complex to basically run it. I would take a pause for a second. Okay, fine. I should continue. So the large inertia and the frequent operation because wear and tear in the whole system, and that has a cascading effect on the other components as well. So control, and secondly, because we have to control the heavy masses of the equipment, it's a challenge, and a reliability we have to ensure it because it is the only crucial component in the whole power place. Not talking about the losses that will incur to the corporation or to the industry, but also human losses that could happen due to any accident because of this. So talking about the forces, we have electrical forces, say a voltage, that is a big factor. You cannot just go and touch a bus bar. You cannot go and touch a cable just like all of a sudden. Or what happens if the cables develop some fault and due to there happens some over voltages and it disrupts the entire system. Then current again related. Then inductance or basically proximity effects. What happens that when there are systems, if you install it near near the power cables, or the communication lines which they won't work, or even some metallic parts. If they're placed too close, then they will, due to proximity, they will develop more voltages and they can give you shocks. And it has happened to me once. Anyways, then forces, structural forces are there. Then civil, you have hydrostatic because of the large amount of water that is stored behind the dam. Then seismic, because of any earthquake, you have to have a earthquake resilient system. Then geological, say there are landslides that disrupt or creates transients, or there are some faulting on the strata. Then mechanical, you have hydraulic components, you the entire turbine unit, the governing system. It is all a hydraulic system. So high pressure system is a hydraulic system. So you need to have a check on them. Then friction, because you cannot just install ball bearings every place in the turbine. It is impossible to install ball bearings. So what you do, you have guide pads that acts as bearings, and the friction between them has to be minimized in order so that low heat is produced. So you use lubricant. And then there are pressurized components as well. Then structural, I told about chemicals. So there are erosional effects of many things. So if you have to optimize the performance, you have to look into the chemical effects of the external forces. Now I shall be showing you some media. How much time do I have? If anyone can tell.
About half an hour.
Okay, half an hour is remaining. Thank you.
Yeah, you can extend it. It's up to you.
No, I have been rushing just because I thought that the time is less.
No, 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 no.
So I will pause my presentation and include the screen. Are you able to see my screen?
Yeah, yes.
Fine. The photographs, are they visible?
Yes, yes, yes.
Fine. So this is the dam as taken from a high level bridge across it. You can see the scale of the dam by seeing the scale of the vehicle. This is a standard bolero. This is a person just walking. These are the labor by construction of energy dissipating arrangement modification was done. So this is the enormous structure. Now you can compare it with the dimensions, right? These are arc interrupting units. So excitation, when you go for excitation, so this is in the middle. It disrupts the voltage in case there is some fault. So you all have seen the MCBs. It's just a bigger version of an MCB. So you have arc quenching medium. You have the fixed contacts somewhere back, and the moving contacts. These are the prime movers or the solenoids that act upon when you give them a control signal. So this whole lever, it gets attracted towards the solenoid. There are contacts that go and meet the fixed contact. While opening, there are basically the arcs. So for arc quenching, you have these systems. This is the whole transformer setup. So the neutral, all the three phases, they are combined to form a neutral, and that star point is then grounded. So you'll learn about it in your curriculum in protection. Ideally, that star point shouldn't have any current through it, but if there is any fault, then the current flows through, and the amount of current that tells how much severe the fault is. Basically, you can balance it. This is another. This is a resistor that is being put in between it. Now, fine. This is the bus bar. These are the links that are used to connect bus bar from one bus bar to the other, because it's generated at 11 kV, and the amount of current, you can see this is the current transformer that is being put. Is it visible to everybody?
Yes.
Fine. So on the right here, it is on the right here, it is the current transformer. So all the amount of current that is going through the bus bar, it is being measured through this. So all the transformers that we're using, current transformer or potential transformer, you're using it for basically two purposes: for protection and for metering. Metering, basically, you need to know how much current is flowing or how much voltage is there. So you use a separate transformer. You don't take auxiliary windings of the existing transformers, current transformers, for the same purposes. So you install different transformers for it just because of reliability. Because reliability is the only thing that is going to save your machine. So there are many protective schemes. Differential current is calculated. If there is some differential current above certain limits, then machine has to be halted, stopped. So many. This is used for protection and metering both. These are all copper strips. So it total 12. Now these are the current transformers, as I was telling that some are used for protection, some are used for metering. So out of five, these four are here, and these two are used for protection. Sorry, for metering, and other for protection. So what you see here in yellow, these are the ferrules for marking. So in a powerhouse, even for a single machine, there are around 5 to 6,000 wires that are coming out of the machine for signals or inputs. You need to identify them. This is this metallic structure. This is the rotor. This was taken while I was standing on the rotor. So just imagine the size of the machine. So this is the rotor. Red, these are the conductors coming out from the carbon brush collector, carbon brushes, which is installed somewhere over here. So what happens that there are slip rings and brushes that transfer the excitation current into the system. So those are placed over here, somewhere here. It comes down and forms a complete circuit. So this circuit is for excitation, the field windings. Okay, fine. These are the blades that provide natural cooling, and this is the salient pole of the machine. So you can see this red. These are the poles. If I zoom it further, you can see these are the things. Fine, guys. I need you to be interactive because this is very important. This is the carbon. This is a slip ring. So positive and negative voltages, the DC voltage is applied in these rings through carbon brushes, and what happens? It takes it downward through these conductors and then into the rotor. So this forms complete field winding system. Now you see here, fluid gear. Can anybody tell what is it used for? A very basic instrumentation. Nobody. Yeah, fine. Mahina Mahmood. Yeah, can you tell? So this is basically this. Teeth are used for counting. The number of teeth are counted on this whole ring. There is a sensor that is being placed over here. It is a proximity sensor, a metallic proximity sensor. So all these, it counts all the teeth. So number of revolutions per rotations per second is being obtained from this gear. There is a sensor that counts how many teeth have crossed through it in 1 second and accordingly gives the RPM of the machine. So this is for speed sensing. Now, as I told that there are no ball bearings and stuff, so we use guide bearings. This is the guide bearing housing, yes, yellow painted structure. And what you see here is the process of aligning the machine. So vertical alignment is being done. So we have approximately 6 to 8 micrometers. These are micrometers you have installed, and one over here and other one opposite to this, one over here, other one opposite to this, and then opposite over here. So all these help in making the alignment vertical, perfectly vertical. So there should not be a single of error, because if the orientation of the shaft is not perfectly vertical, it will create stresses on different guide bearings, raise its temperature, it will heat up the oil, overheating will be done, and the machine will collapse. So this is at the time when there was some flooding through the shaft of the powerhouse. So here you see in the background are the for excitation, the DVR panel, digital voltage regulator. So this causes the excitation voltage. It comes into here and then it goes down into the rotors. These three are not water conduits. These are the bus bars that are coming out from this generator and going into the generating transformer. Fine. This is some view of the shaft. So you have a hole through the shaft that goes from the draft tube to the top. So it is because when there is water conductor and the water is suddenly let in, then it creates a vacuum. In order to compensate for the vacuum, we provide a shaft that sucks in all the extra air and creates a pressure balance. Okay, this is a reactor. Now this reactor, it's nothing else but a component that helps to stabilize the reactive power of the grid. So we installed recently, last year we installed a bus shunt reactor, because the voltage rated voltage level was 400 kV. However, due to the long length and the Ferranti effect, the voltage levels usually it happened to be 420 kilovolt, and those extra 20 kilovolt stress on every equipment of the power plant and on the switchyard basically is very dangerous. So in order to compensate this extra 20 volt, we installed a shunt reactor. So this is how a very big structure is shifted from a trailer to its final resting place. You can see it looks like just like a transformer. It is basically a transformer without a secondary winding. So the primary winding, one inside here, second here, and third here, they are all connected, and then star is ground. Fine. This is a snapshot of the transformer oil that is going to be filled into this. So just see this is a standard barrel, and there were approximately 200 to 300 barrels that we used. These are the contacts of your turrets. I'll show you in the coming slides. These are the turrets. This is not necessary. Fine. This is a current transformer. So the power coming from one end going to the other. You have it for protection and metering. This is a current transformer. These are the corona rings, if you remember. This is the complete layout of the switchyard that we have. So all the generating units, it is feeding in the power into these main bus A and main bus B through the circuitry. We have isolators, circuit breakers, fine. Then we have a bus coupler so as to join these two buses. This is while constructing the bay. Yeah, this must be interesting for you. This is a control cable that is being labeled. So what happens that in industrial norms, basically, you cannot have an electrical engineer everywhere to do all sorts of work. You need to have technicians as well. So there is a bunch of 5 wire in a cable. So there's a 5-4 cable, and in order to provide nomenclature, what happens is this is an identifying wire. So clockwise or anti-clockwise, you create a norm and you number it accordingly. Then you put the ferrules and finalize that this wire is going to this particular place. Because there are so many cables, you cannot just have numbering on each and every single coming from the manufacturer themselves. This is me, and behind me are the numerical relays, the back portion of the numerical relays. You can see the dressing, how finely they have done. So all these wires are coming from various equipment in the switchyard. They are coming, and all the processing on what is the voltage level, the phasors, everything has been computed inside this numerical relays. So it keeps a check on how the healthy system is. And for communication, we have OFC cables. So these all collect the data, have it for future troubleshooting. This is your oil housing component of the this is the Buchholz relay. You may have heard of it. This is very important for it is a very basic mechanical device, but it is very much required for the protection. These are the radiators, fins. Now this is the turret that I was talking about. So it is joined over here. This is the hole where these people were standing. So when you look through this, you get to see this. So these are the current transformers. You can see the winding. This is inside this. These are this is the wall of the reactor, and these are eddy plates. So the excess magnetic field, the eddy field, so they are circulated within this. So no stray magnetic fields disrupt the voltages outside. This is how it is being inserted. These are the connecting cables from the core. So this is core of one phase. You can see these are the core, the complete setup. This one. You can see the windings. So I was very fortunate to be because you can go inside a transformer because once commissioned, it will never be opened throughout its lifetime. These are certain other things. Now, fine. You see this. I want your attention over here, guys. These are nuts and bolts with the sides fine. So they have these sharp edges. And what happens because of these sharp edges? There are corona. ये अपना कोविड वाला कोरोना नहीं, ये इलेक्ट्रिकल वाला कोरोना. ये एजेस के पास इलेक्ट्रिकल स्ट्रेस बहुत ज़्यादा रहता है. ये यहाँ से किसी भी मेटालिक स्ट्रक्चर पे आग क्रिएट कर सकते हैं या इन स्ट्रेसेस की वजह से ट्रीइंग हो सकता है. तो इंसुलेशन बेसिकली खराब हो जाएगा. उसको कवर करने के लिए ये कोरोना कैप्स लगा रखे हैं. तो दिस कम्स ओवर इट एंड द इंसुलेशन इज सेफ. Now these are some contacts of the turrets. You can see these are the radiators. This is the core and this is the partition plates that I use to again to reduce the losses, stray losses. This is a very well furnished, you can say, a reactor. And again the whole barrel setup. These are the connections from the current transformer. So they are named as one different. They are given different names. So you just have to identify each one of them by doing a continuity test. And all the instrumentation data for metering or for prediction is taken out from here. So this is the size of basically a turret of generating transformer. You can compare the length with this map. And if you can see, let me zoom in a bit. Is it clearly visible? There's a scar on the face of the threads. So
Yes, sir.
this these threads, they have been disfigured by electrical sparks just because the bolt was not tight enough. And by tight enough, I mean that it has to be done very by large forces, so that it doesn't loosen up because of temperature variation. The thing that I talked about temperature variation in about the dam, it also applies to all the other metallic structures. This was the bolt that was holding the cable. This cable, these cables, you can see. I'm not sure if it is quite much visible. These are the bolts. So this places over the turrets. So what happened that one of these bolts had a loose nut, a slightly loose nut, and it caused the sparking. Because of the sparking, these threads were destroyed, and these threads, in addition to getting defaced, what it did that it further reduced the mechanical strength, the force, the pressure the bolts are putting. So again, more flaring and flashing was observed. And this is installed at the top of generating transformer. and it is at a very high. The height is too much, but still because of this, you could hear the sparks from around over 100 to 200 meters. And this is a normal M12 fold. That means the diameter of this is 12 mm. So this is normal household bolt that is being used. This is these lines, if you see, for fire protection equipment. One is the control line, another is the extinguishing line. These are the breather, so that no air inside the chamber of the oil reservoir comes contaminated with moisture. This is the control line. And this is the data of temperature or pressure you get from the control line. And there are cables running which go into the control room and tell. So this is a reactor after final setup. Very fortunately, I was a part of the team that installed this. Okay, fine. This is another great thing that you should see. This is the string. These are the buses. So this is bus A or bus B, I don't know. So R by B phases. And here is the person who is fixing some cables from the buses. So these hanging cables he's fixing now. So that is the proportion, that is the size of these insulators and the structure that is being used in industry. Fine. So this is the enormity of. I have a view zone there. And these are the corona rings in an isolator. So when they open, so first these two rings interact and it doesn't damage the main contacts. This is the flood passing through the dam. So these are the spill gates behind me. And this is a catwalk, basically not much importance, it's for monitoring only. And this is the ski jump that is being created by the flow of this water, you can see.
That was quite amazing.
Yeah,
Okay,
I have
so we have
some
4 more minutes left. I guess we
uh,
should move towards question answer section.
so as you can see, this is the work of spillways. It's channelized. Okay, coming back to the presentation. So any question and answer?
That was an amazing presentation, and the photographs were also amazing. I guess we are pretty much lucky that we are able to enter the transformer as well with you. So let's move towards question answer session. Shark, do you have any question?
Yeah. First of all, thank you, sir, for such a nice presentation, and you have talked everything almost about hydro. But I have a question that approximately the electricity generation in India
You're
is
not audible.
approximately. Hello, hello,
You're not audible. You can please repeat. You can please repeat the question.
hello. Am I audible now?
Hello.
Yes,
Yeah,
Shark,
yeah.
you're audible now.
Okay. First of all, thank you for such a nice presentation, and you have talked almost everything about hydropower plant and its financial aspects and maintenance. So I have a question that approximately 70% of the electricity generation is by the thermal power plant, and
Mhm.
somewhat and less amount by hydropower plant. Approximately, we can say 16% and 3% by nuclear power plant.
Yeah,
So can you
I just
mention
hate
some
to interrupt, but I
specialities
have
that?
just a second. Sir, just a second. I have shared a form. So anybody who has questions, you can just directly go into the Google form and and ask me. So I will be collecting the responses. Yeah, you may continue now.
Okay. So, sir, I was telling that approximately 70% of the thermal, matlab, electricity generation is by thermal power plant. That's we are burning fossil fuels for the generations, and we are more polluting and degrading the environment. And for the case of hydro,
Mm-hmm.
approximately 16% is generated by the hydropower plants, and it is very cheap, and it is a very clean source of energy. And
Mm-hmm.
so, why we are not moving from thermal to hydro? power plants or nuclear, it is also it is an, and it is also very cheap and clean energy source. So can you mention some challenges that
Okay, fine.
why not moving from?
Yeah. May I know which year you are? Am I audible?
Yes, sir, you're audible. So basically, Shahrukh
Yeah,
is
Shahrukh,
from
which?
third year electrical engineering.
Okay, fine. Third year. So, okay, fine. So I think this must be a question for a lot of people. It's a very conceptual question, but the answer to it you don't find it in books. It is firstly because if you see that apart from few backwaters rivers or from Himalayan rivers, the other places they don't have power plant that has a capacity of 1000 megawatt that a power plant has. It is a very big challenge because we don't have that much water. Firstly, secondly, in order to create that well of water, you need to rehabilitate so many people. We are talking about the population of India is rising by 10 years. In near 10 years, it will surpass China. So the population density is so huge. You cannot just transfer all those people from one place to the other, including their livelihoods. Second, fine. So rehabilitation is one issue. Resettlement is an issue. Then availability of water is a major issue. So you cannot just have a dam built anywhere near a society or at any place where you think you may get water. For that, you have to do a lot of study based on how much rainfall comes to that place, and based on that, you get to design a power plant. Thirdly, when we talk about even for the Ganga or the Brahmaputra basin, these rivers, they have a lot of water. The Indus has a lot of water, but that has to be utilized for irrigation purposes as well, for drinking water as well, for fisheries as well, for inland water transport as well. So you just cannot hijack all the water for your electrical utilization. Mostly the cost of building a initial cost of building a hydropower plant is way more than developing a thermal power plant or a nuclear power plant. Coming to thermal, see you that needs only coal and coal linkages and all these coal blocks you can mine. Some of the coal you are getting as imported from Australia or other countries. Rest we can manage on our own. So coal is available, although I know it's not a good option, but for the gap that has been made, coal is available. The hydropower plants are basically peak generation plants because they can be started and stopped very easily and in a very small amount of time. But you cannot just keep them running for say the whole year. That will not serve the purpose. About the nuclear power plants, so basically, nuclear power plants are all about the nuclear technology and the safety related to it, the radiation levels and everything. So you just cannot have a nuclear power plant. It is very costly. First of all, there are so many clearances you need to have for that, and those are not just only national clearances, the international clearances as well. And the big challenge that you face is protecting against the whole uranium. You have to dispose it of in a very safe location. You must have heard of the Chernobyl incident. Most uh, old nuclear fuel, they are radioactively active today. So you need to see all those things. Fine. Any other question?
Okay, sir. I understood that the lack of availability of resources is the problem, and the cost related to setting up of hydropower plant is more.
Mm-hmm.
So that is the issue, huh?
Yeah. That is a big issue.
Okay, sir.
Actually, you don't see what happened in Narmada Bachao Andolan. Everybody knew that these projects on Narmada Basin, because see, it is not fed by snow or glaciers. So there is rainwater in particular season, and then throughout the year it is dry. So everybody knew that having a dam would be very beneficial for the entire nation as well as for the local communities as well. They were being provided with jobs as well. But there are many other political issues that arise. there are many other emotional and sentimental issues that are associated with developing hydro power plant. So that is the main reason that we don't have any hydropower plant projects coming up. And there are some government policies. Once you see that the 5-year plans when they are formed, or the every year's budget what is formed, you see that there how much expenditure is being done on power sector, or in education sector, or in medical sector, or in defense sector. So those are all government policies. It's up to the government what they need. They can afford, definitely they can afford the people getting 4 hours or 5 hours of electricity, but definitely they cannot afford that there are infiltrators on our borders. Fine. So it is basically due to that reason that government decides the priority of which sector to develop at what pace. And unfortunately for power sector, this is a low point in these 4 to 5 years. So, but anyways, hope for the best till the time you graduate. Hopefully there would be more jobs. Next question. Can I have a next question? Am I audible?
Yes, sir, you are audible. It was quite nice
Yeah.
session. The
Should
link
I
is
ask individually? Emma Razim, are there any questions? Alina Naz, Fazan Mohammed?
so actually we are running out of time. So I guess
No,
the
no, no.
question answer form is open for all till tomorrow, I guess. So
No, no,
we
that
should
will be
not.
there if you need to contact me. So you can
Okay.
have my email ID.
Yes, sir.
So it is farazahmad@zhct.ac.in.
Amazing, amazing. So over to you, Mahina, for the thank you note.
Assalamu alaikum, sir. Myself, Mahina Mahmood, coordinator online webinar IEEE Students Branch at CTAMU. I feel highly privileged to be presenting the vote of thanks for this session. First of all, I would like to thank Mr. Faraz Ahmed, sir, for accepting our invitation and sharing his valuable knowledge and experience about the topic. Sir, we are highly grateful to you for sparing your valuable time despite of your busy schedule, and we are really looking forward to have you again with us, sir. Secondly, I would like to thank Mr. Mohammad Zaid, sir, for organizing this session on the occasion of IEEE Day. I would also like to thank all the participants who joined us for the session and made this event a
I'm
great success.
really sorry. Can you please
Thank
repeat?
you.
Not listening. Yeah. Hello.
Hello, yes, sir.
Yeah, you may repeat.
Myself, Mahina Mahmood, coordinator online webinar IEEE Students Branch ZCT AMU. I feel
Okay.
highly privileged to be presenting the vote of thanks for this session. First of all, I would like to thank Mr. Faraz Ahmed sir for accepting our invitation and sharing his valuable knowledge and experience about the topic. We are highly grateful to you, sir, for sparing your valuable time despite of your busy schedule, and we are really looking forward to have you again with us, sir. Secondly, I would like to thank Mr. Mohammad Zaid sir for organizing this session on the occasion of IEEE Day. I would also like to thank all the participants who joined us for this session and made this event a great success. Thank you.
Thank you, everyone.
Thank you.
Thank you, sir.
Thank you very much, sir.